So we have 20 grams of water, 20 grams of water at, at 10 degrees Celsius. And the temperature of this water has to be risen to 80 degrees Celsius using steam. By supplying steam, you are increasing the temperature of 10 degrees Celsius of 20 gram water to 80 degrees Celsius. And we don't know how much quantity of steam is required. But we know the temperature of the steam is 100 degrees Celsius. Let's call the mass as m dash. So using this steam, you are increasing its temperature. Finally, the steam is also attaining a temperature of 80 degrees Celsius. For that to happen, the steam has to undergo two processes. First one, the steam has to convert itself to water at 100 degrees Celsius. Water at 100 degrees Celsius. Then it has to lower its temperature to 80. Clear? So the steam has to undergo two processes. Anyway, our equation is the steam is that thing which is giving the heat and the water is that thing which is gaining the heat. So heat lost by the steam is equal to heat gained by the water. Since this steam has to undergo two processes, that is, what first thing is the steam has to convert itself to water. It has to is a supply of m dash times LF heat must be used, where LF is the latent heat of water. In order to convert the gaseous state to liquid state, conversion of steam to water, a quantity of m dash LF must be used. A quantity of heat of m dash LF must be used. And for the second process, for the conversion of water at 100 degrees Celsius to 80 degrees Celsius, a heat of m dash C delta T must be used. Let's call this as delta T dash. For the rise in temperature, a quantity of heat of m dash C delta T dash must be used. So heat lost by the steam will be the sum of these two heat energies, that is m dash LF plus m dash C delta T, which is equal to, this water has to rise from 10 degrees Celsius to 80 degrees Celsius. So the heat transfer here will be mc delta T, which is equal to mc delta T. Substituting the values, m dash you don't know, m dash, and the latent heat of water is 540 plus m dash. For this process, the specific heat capacity is 1 into the change in temperature is from 100, you are lowering it to 80, so it is 100 minus 80, which is equal to, mass of the water here is 20, that is equal to 20, and the specific heat of water is 1, and the change in temperature is, to increase from 10 to 80 you need 70, or 80 minus 10, that's the change in temperature. So solving, you get 540 m dash plus this will be 20 m dash is equal to 20 times 70. So this is equal to 560 m dash is equal to 1400. So m dash is equal to 1400 divided by 560. It will be 2.5, which means 2.5 gram of steam is converted into water. So the total mass m will be the mass of the water 20 plus the mass of the steel converted to water, that is 2.5. So it is 22.5 gram. That's the answer.